Thank you, Alyssa, for the question. I did not forget. But before we do this question, let's do some warm-up questions. That means that we're going to talk about 99 plus 7. So the first thing we're going to do is we're going to add 99 onto the abacus. When we have 99 on the abacus, the question now is I want to add the 7. Notice this is the 7. I don't have any beads to add the 7. Now what do I do? Well, if I look at it, right, if I look at this question, if I look at this column, I need to add the 7. I can't do it. So what do I do? Well, we know that the formula is plus the 7, right, is equal to plus the 10 minus the 3. So what we're going to do is we are going to plus the 7. When we plus the 7, we need to remember plus the 7 is equal to plus the 10 minus 3. So that's the question we need to do. When we look at it, right, when we look at it, we're adding the 7. And what we need to do is we need to plus the 10. Now notice I need to plus the 10. Plussing the 10 is on this side over here. So what's going to happen is I need to take away the 3 and then plus the 10. Notice I don't have enough beads to take away the 10. So if I don't have any beads to take away the 10, then what do? I need to plus the 10 minus the 9. So this is a two-step equation. So what I'm going to do first is I'm going to take away the 3 and then I'm going to add the 1. When I add the 1, remember when we add the 1, what do? We have to plus the 10 minus the 9. So we got to remember to plus the 10 minus the 9. When we look, we want to plus the 10 minus the 9. So just as we did here, we want to plus the 10 minus the 9. Oh, that doesn't make sense. There we go. Plus the 10 minus the 9. When I line it up, this is my 0, this is my 10. So I'm going to plus the 10. And then I need to take away the 9. So I'm going to take away the 9. So my final answer is 106. Welcome everybody. Hey, is cool. Welcome, welcome, welcome. I was just talking about how to do a two-step equation. I am very well. How are you doing today? Is cool. How are you? Okay. So the first thing we're going to do is we're going to read the abacus. Thank you so much for liking the live. We're going to read the abacus. The first thing we're going to do is understand that there's this horizontal bar. This horizontal bar is what tracks our beads. These are our beads. These beads help us track our numbers. So when we count 1, 2, 3, 4, because these beads are touching this horizontal bar, now they're being tracked like a GPS, right? Or the CIA or FBI. I can't remember. Anyways, so this is 4, and then the top bead will always be 5. Hello, Suri. So all the top bead is 5. Because the top bead is 5, this is going to be counted because the top bead is touching the horizontal bar. So we have 5, 6, 7, 8, 9. Does that make sense? So after 9, we have 10. This looks very similar to this. Notice the difference? They're quite similar, but the only difference is that they have a different place value. What does that mean? Every column is a place value. Hello, Matt. Welcome back. Welcome back, everybody. Welcome back. So thank you so much for liking the live. So what we're doing is we're looking at our place values. We have our ones, our tens, our hundreds, thousands, and 10,000s. Hey, Pay. Thank you for the follow. So when we look at it, we have our place values. Abacus is really good at helping us keep track of our place values. If anybody has any questions, let me know. Let me know. There's no dumb questions except for the questions you never ask. I don't know. That's what they say, but I don't know. Anyways. All right. So what we're going to do is we're going to count again. Notice we have 1, but this is not 1 because this is on our tens place. This is 11. This is 10, this is 11, and then this is 21. So notice we do 1, 2, 3, 4. Because we are because the beads are touching the horizontal bar, we are counting. Hold on just a minute. Okay, I'm sorry, I'm back. Okay, so we are looking at the beads. So this is the 4. All the top bead has a value of 5. Hello, Trippy, thank you for the follow. So this is a value of 5, no matter what. So these are all 5s. If I did this, this would all be 5. So if I was to rewrite it, it would be 5, 5, 5, 5, 5.55. That's what this means. Make sense? So what we're going to do is we're going to continue to count. The thing is with the abacus, we need to understand how to read the abacus. When we understand how to read the abacus, then we can actually do adding, subtraction, multiplication, and division. So what's going to happen is we have 5, and then notice if I did this, this would be 6, and then 7, 8, and then 9. Then what's after 9? Just like how we write. What's after 9? We have 9, then we have 10. 10 is 1 and a 0. That looks very familiar, doesn't it? Doesn't it look kind of the same? So we have 10, 11, and then we have 12, and then 13, and then 14. And again, because this is the toppy, that will be 15. So let's count by tens. So this is 10, 20, 30, 40, and then this is 50. After 50, thank you for the follow. I am wealthy. I wish I was wealthy. I'm sorry. So if this is 50, how do I know this is 50? Because this is my tens place. Because this is my tens place, I have my ones, my tens, my hundreds, my thousands, my 10,000. So my 10, I'm sorry, this is 5, this is 50. 50, 60, 70, 80, 90. Because this is 90, now what's after 90? 90 would be 100. So if I just wrote it, oh, okay. Sorry, I don't have the time to learn this now, but I'm subscribing to see the next lives or videos. Great, I am wealthy. Thank you. Not a problem. So this is 100. Because this is 100, we can start counting by hundreds. So 200, 300, 400, and then again 500. Looks very familiar, doesn't it? So this is 5, that's 5. But if we look at it, this is 5, this is 6. So we can call this 600. 600, 700, 800, 900. And then we have 1,000. I am recommend. Is cool. Thank you so much. Thank you so much is cool. Hi, Pay. 9 groups of 10, then 1 group of hundreds. 9 groups of 10, and then 1 group of 100. Yes, yes, it is. Thank you, Pay. What we do is actually, we don't talk it that way, right? What we just call it the numbers. We just say 1 and 9. Yeah? But yeah, that's exactly right. Abacus doesn't really do quantity. You could do quantity, but we actually do place values. So you could do the quantity, but the place values is more important. Not more important, but it's the next step of learning how to read. The next step of how to read a number, right? So when we talk about ones and tens, we don't say 99. We don't say 9 groups of 9. We say 99. So the way we talk about it is how we write it in Abacus. Does that make sense, Pay? So when we say 73, do you say 7 tens and 3 ones? 7 groups of tens with 3 ones? We don't talk like that. So it makes sense, like, yeah, if that makes sense to you, but it's just like how we write. So when we write, we were going to write, we said 9 groups, so it's 91. So 900, 190. Yeah, I only use that as an explicative. I don't even know that word. Explicative. Oh, explanation. Explanation or I don't know if that's a real word. Yeah, explanation. Thank you. I'm the reason why I'm laughing because sometimes people like put in like acronyms and I have no clue what the acronyms are. Like NGL, and I'm like, what's NGL? I'm old. So I don't know the new terminologies. Like my kids are talking about vibing, and I'm like, vibing? Like listening to music? That's what you call vibing? So please excuse me. I'm old and I don't know the new terminologies. Yeah. Oh, see, I don't know. I see, I don't know that one. I know you, no, I don't know that one. I don't know that one. IYKY, you know, I know you, we will, oh my God. If you know, you know. Oh, I see. If you know, you know. We will let you know. Thank you is cool. All right. So, going back to reading the abacus, because that's what I know how to do. Anything about the abacus. Thank you so much is cool. There was another one. ACL. And I'm like, that's not a real. Anyways, okay, sorry. Okay, I'm going to continue. So, what we're going to do is we're going to continue to count because we need to understand how to read the abacus. I'm vibing with this. Yeah, RN. And I was like, what the heck? The only thing I know is on my way. OWM. And I'm like, okay, that's all I know. Anyways, okay. So we're going to do, you guys are so funny. Okay, so what we're going to do is we're going to continue to read the abacus. Why? We're going to continue to read because understanding how to read it, then it makes more sense. So let's do this number. Let's do this number, 555. When we do 555, it's 558. That's what 558 is. And then what I was doing in the beginning of my live was I was actually talking about two-step equations. But of course, what we need to do is understand how to add. When we know how to add, then we can start going into formulas. After the formulas, because there's two sets of formulas we need to know. After the formulas, and I'm kind of excited. I wrote out this thing. See, I'm not going to lie. By the way, I think that's what you're talking about a minute. Yeah, that's the one. That was the one. There was somebody that said, somebody said that this is really cool, NGL. And I'm like, what is NGL? Anyways, so I was working on my book, and one of the things I was noticing is like, oh, what I need to do is I created a chart. So what we're going to do is we're going to utilize the bead. Why? Because what's going to happen is if I do 1 plus 2, we have enough beads to add the 2. What we're doing is we're doing simple adding. So that means is do I have enough beads? Hi, Lilith. Let me know if you have any questions. Because if you don't tell me that you don't understand, then I'm not going to know that you don't understand. Because it's about a communication. It's about comments, right? It's about having a feedback loop. So let me know if you have any questions. So what we're doing is we're adding. We have 1. Notice that we have the horizontal bar. When we have the horizontal bar, this is what tracks, right? Like a GPS. GPS tracks. And everybody's always listening to us, right? Like I could see the blue light. My thingy thing is listening to me. Okay, but we know, right? So the horizontal bar, if we're a horizontal bar, it's being tracked. So anytime the beads are touching the horizontal bar, it's being tracked. So we have 1, 2, 3, 4. All the lower beads has a value of 1. All the upper beads, all the top beads, this is the top bead. Anything above the horizontal bar, this is the top bead. When the top bead is touching the horizontal bar, this is being tracked. This is a value of 5. This top bead is a value of 5. So now we can count on. Counting on is a kindergarten skill that we're being taught. So we count on 5, 6, 7, 8, 9, and then what's after 9? 10. When we look at it, this is 10. Just as we write, we have 10. Hello, Oblivious Artist. That's a fun name. Okay, so this is 10. How do I know? Because we look at our place values. When we look at our place values, we have our 1s, our 10s, our 100s, our thousands, and our 10,000s. Thank you guys so much for liking the live. So afterwards, we're going to still continue to add, right? So when we want to add, let's say 9, then we just add the 9. Do we have enough beads to add the 9? Yes. All we got to do is just add the 9. And there we go. We add 9. So 10 plus 9 is 19. Easy? Easy? Simple to use, easy to understand. So when we start going in, it's like, okay, well, what happens when you don't have enough beads? Well, this is where we start talking about formulas. The first formula that we're going to start to understand is, what is the first formula we're going to understand? We're going to understand this one. We're going to add a 4. So the question is 4. The question is 4, and then we're going to add another 4. Notice I don't have any more beads to add the 4. Well, in school, we're teaching everybody, we're teaching all the cool kids what the number is. We're teaching all the cool kids how to make a 5. How to make a 5 is plus the 1 is equal to plus 5. This is what we're going to do. Then what we have to isolate the variable. What variable are we going to isolate? We're going to isolate the 4. Why? Because our question is 4 plus 4. Hey, Ruben! Welcome back! So this is 4 plus 4. So what we're doing is we're going to look at our add-in. Our add-in is what we're doing. Because we don't have enough beads for 4, what we're going to do is we're going to look at this concept. Your abacus is on the way, just so you know. I don't know if I delivered it on Monday, so I don't know if you're going to, and I gave you the tracking number. Did you get the tracking number? I want to make sure that communications there. Okay, so what we're going to do is we're going to isolate the variable. When we isolate the variable, what does that mean? We got to take this 1 and we got to move it to the other side of the equation. When we do that, what does that mean? We're going to make the 4 by itself. Okay, what does that mean? So we're going to make it 4 by itself like that. And then we're going to take this 1 and we do a subtraction. So notice if I do 4 plus 5, 4 plus 5 is not balanced. So we got to balance the equation. This cannot be a 6-7 situation. This has to be balanced, right? It can't be 6-7. It's got to be balanced. So we're going to minus the 1. Because we minus the 1, now we can utilize this. We can utilize what we have. So what does this mean? Now, if I look at it, I can add the 5 and I can take away the 1. So then my answer is 8. Now, why are we doing this? Because this is a fundamental concept. This concept will scale to all sorts of places. The only thing is we need to understand how to use it right now. So when we understand how to use it right now, we can use it in any situation. It doesn't have to be a doubles plus 1. It doesn't have to be like everybody was talking, not everybody, but in school we were taught that we had to do 4 plus 4 and we had to memorize this. But in Abacus, we don't need to memorize this. What we do is we just need to understand how to do the concept, how to do the core concept, which is plus the 4 is equal to plus the 5 minus the 1. This is a core fundamental concept. Does that make sense? Thank you so much for liking the lives, everybody. Thank you so much. But does that make sense? So, anybody have any questions? Anybody lost? Anyone's lost? Let me know. Let me know. Forever hold your peace, because I'm going to continue on. So, I think this worked out really well. And so what we did here was we moved it over. And I think that worked out very well. I like this thing. I like this thing. So, yeah, right? So then what I'm going to do is we did the adding. What happens is we have to subtract. When you when you add, you have to subtract. That's the only thing you need to do. When you add, you have to subtract. So again, what is the formula that we need to do? We know this. But now it's going to be opposite. We know that if it's plus 4 plus 1 is equal to plus 5. We know this. Now, what we're doing is we're going to subtract. When we subtract, we have to minus the 4 minus the 5 minus the 1 equals minus 5. Right? If minus 4 minus 1 is equal to minus 5. That makes sense. I hope that makes sense. So what are we going to do? We're going to isolate the variable again. We're going to isolate this variable. Why? Because what we want to do is we want to do a takeaway. So if we do 5, let's do 6. Let's do 6. So we do 6. I want to take away the 4. There's not enough beats to take away the 4. We are going to utilize our 5. We're going to utilize our 5. We got to make our 5s work. We got to make our numbers work. There's no there's no freeloading numbers. None of the numbers are freeloaders. So what's going to happen is I'm going to make this 5. When we do that, we have to isolate the variable again. Again, we have to isolate the variable. We know how to do it for the plus, right? So remember the plus was plus the 4 is equal to plus the 5 minus the 1. But now we're doing negative. What happens? This needs to go to the other side of the equation. So we're going to add each side. What we're going to do is we're going to minus the 4 equals minus 5. Again, this is not a balanced equation. Because it's not a balanced equation, to balance it, we need to plus the 1. Why are we doing this? This seems so complicated. It's not complicated. It's just versatile. It's versatile and it can go and it can scale. Because once you understand this, then we can go anywhere and everywhere. It doesn't matter. So here's my question is 6. If I have 6 and I want to take away the 4, I cannot take away the 4, so what do? I have to minus the 5 and add the 1. So I'm going to minus the 5, I'm going to add the 1. So my final answer is 2. Right? Make sense? So yeah, I rewrote the formula. But there was more to it. And then, I don't know if anybody's watched this, but dude, where's my car? That's what it reminds me of. And then, okay. So this is what we call commutative property, where we can flip the two and it doesn't matter, right? As long as the answer is the same, these two and these two, it doesn't matter. So that's the same thing when we write it out. And then this is here to make sure we understand. So we can go on to even more. So if we did 7, right? If the question was 7, if we did 7 minus 4, again, it's the same thing. We have 7 and we take away 4. To take away 4, all we got to do is minus the 5 plus the 1. Minus the 5. Can we take away the 5? Yes. Minus the 5 plus the 1. And my answer is 3. Oh, I do like this. This is well done. I'm so good at this. I just made this morning, and that's why I didn't go on live this morning, because I was working on my book, and so I was trying to figure out what's a better way to explain it. But I do like this. It's a really good setup. So what we did is we subtracted the 4, and then we did the adding of the 4, and then yeah, this is I'm very excited for my new book. Okay, but that's the little gist of it. So what are we going to do, right? Yeah, it makes sense, right? So that's the thing. And that was the other thing. I was trying to add some, what do you call it? Math terms. So this is a math term. Abacus doesn't use math terms. I'm telling you the truth. We don't use math terms. I had to find this. Hail Odyssey! So, when is your new book coming out? I'm still working on it. I'm gonna, I don't know. I'm working on it. Right now, I think I have it halfway done. I'm still trying to figure out if I want to break it up into small number, how I want to break up the questions. But I have maybe half of it done. But this is for adults, and then this would be for kids that are old, 10. I was thinking about 10 years old, and I was trying to figure it out. So it'd be because I made some already for preschoolers. So I made some for preschoolers. And what happened is this is just about number recognition, bead recognition. And it's just activities and stuff. See you next time, Pay. Not a problem. I'll see you later. See you in my next live. Do you have any books for high schoolers? That's what I'm working on. And I think that's why I made this. And there's an actual chart here. And this was an explanation. And and so we would work with bigger numbers, but I haven't, that's what I'm doing, is the books for high schoolers. But it'd still be just basic arithmetic, if that's okay. You know what I mean? This one here, this is not to fill out. This is just for me to show you. But there's a whole chart, how to do this. Yeah. Oh my, I'm probably going to have it when you're done with, oh, wait! Yeah, I'm trying to get it done. I was looking at it and I was trying to figure out how far I should go, because I don't want the book to be too big. It's going to probably be about 100 pages. This book is about 100 pages, and this one has this is filled with activities, but this is for younger kids. This is for kids maybe 6, 7, 8, and so that was the idea. The idea was to try to. That was the thing. My original thought was to make a line of books for kids, but I didn't know that people that are not children are interested in it. So that's why I've been trying to push to make it more, I'm trying to make it more adult-like as opposed to kid-like. Because this one has a lot of, this one has cats in a tree. Some people like it, some people don't. But this one was meant for kids to get to understand how to do the cats in the tree, which is what we did here, but we called it utilizing the 5 bead. So what we did was, instead of telling you how to isolate the variable, I'm just telling you to use it, right? So this one says if I have 5 cats in a tree, I always have 5 cats in a tree. So here's 2, so I'm going to add 2. So if I add 2, and then the question is do I have enough beads to add 4? No, I don't have enough beads to add 4. So what I have to go to the cats in the tree. There's always going to be 5 cats in the tree. 1, 2, 3, 4, 5. So you grab 4 cats, and then 1 cat runs away. Sometimes I like to do harder problems so I feel smarter. And then take away 1. So 1 cat runs away. So then the answer is 6. So that's why I had it this way. But I don't think I'm not gonna add this to the adult version or the high school version. Yeah. But yeah, good afternoon, Beal. How's it going? Good afternoon. Yeah. I was just talking about all the stuff. I was just talking about how to add and stuff. So if we talk to this, let's go back to here. So what does this mean? Well, now we're going to do, we know how to add do we know how to add the 10? Actually, I didn't do that. So what we're going to do is we're going to add the 10. Thank you for making them look good. What age? Ruben, what age? I was looking for kids that are 3, 4, 5, and 6. So that's why I did the preschool one, and I was trying to get them to. I was trying to get them young. So this one was about bead recognition and number recognition. Thank you for making them look good. I hope they are. I hope they are. It takes a little bit of, planning and pre-planning, and I wish I could spit it out like AI, but nothing that I know does what I do. Until I give enough samples, I guess. So going back to Ruben, what I have it is I have like activities, and so this was kind of geared towards 3 to 5, sometimes 6, but they don't need to really practice their handwriting. This one was more about like kind of practicing and understanding the relationship, and so this one was after they understand the relationship, like what's bigger than and what's less than, because they got to do that in kindergarten or preschool. Then they start doing it into they start adding and subtracting. So when we know how to add, we will know how to subtract. That's the one thing that you need to know. Like we need to know how to balance it. And then here I have it where there's activities. So after they understand how to add a 3, then there's an activity like color by number. And then after that, after this book would be the +5 book. So the +5 book is for a little bit older. The reason why is because it's the next concept. After we learn how to add, simply add, meaning that do we have enough beads? So if we do 5 plus 3, is there enough beads to add the 3? Yeah, there's enough beads to add the 3. So after we do this, then the question next goes to, if I want to add 4 and I want to add, and I want to plus another 4, do we have enough? Now we have to start doing formulas. When we start working with our formulas, that's where this book comes in. Oh, that's where this book comes in. And this is where we talk about how to add a 5 and how to make a 5. And then after that, there is I got like a year or so to learn. And then there's plus 10. I got like a year or so to learn. Is it because, yeah, I'm not sure what that means. Ruben, it took me a while. It took me, like, I learned it when I was in my 30s, and it took me a while to really understand it. I was able to show him along. Oh, yeah. So how old is he? I'm sorry, I forgot. And the thing is it goes all the way to like 5th grade, 6th grade, because you can do multiplication, division on it. You know Russian math. You know Russian math because that's crazy there too. I don't know Russian math. It's above my pay grade. Hi, Ivan. How old is um because because my kids are in 6th grade and he still uses the abacus, because the abacus sometimes he gets a little mixed up. I still have him go back to refer the abacus, if that makes sense. So he's 11 now and he still uses, he sometimes he uses the abacus, sometimes he doesn't. Russian math, I didn't even know that's a thing. Yeah, that's a thing. That's a thing. But I don't know Russian math. It's really abstract from what I understood, but I didn't go into it. I had a friend's kid that's gone into it. We have a Russian math school up the street, and they went to it. So, um, it's a video. It's a video with constant numbers flying by, and at the end, you say your answer. Oh, interesting. That's like flash. That's like flash abacus for us. So it's called flash or anzan. And so what it is you keep flashing the numbers and then you tell the answer. Yeah, we do. I don't do that really. I just want to make sure that kids are happy and fun to play with, because I don't. Because I'm trying to make it more mainstream, and mainstream doesn't do any of that. Mainstream just talks about like how to add, subtract, multiply, and divide. So, and then I don't know if they have Russian math competitions. I know they have. I know they have abacus competitions. So what we're gonna do? What I'm sorry. What we're gonna do is we're gonna count. So we have a few new people coming in. So let's count it one more time. We'll do 1, 2, 3, 4. Anytime the beads are touching the horizontal bar, we have 4, right? This is 4. This is 1, 2, 3, 4. Because the beads are touching the horizontal bar, these are being tracked. Because these are being tracked, this is tracked, but this is 5, not 1. The top bead is always 5. I always see people coming so fast with these. I always see people going so fast with, yeah. It's a practice. You have to practice it. Like, I don't practice it enough to do it. But I mean, I kind of see some stuff, but I don't practice it enough to like be really quick. Because it would be hard to teach if I was really quick. So I think that's why I'm okay with not being quick. So this is 5, and then we have 6, 7, 8, 9. Are my kids quick? They can be if we practiced. They know how to use it. Like if you give them an abacus, they'll be able to figure it out, but because it's in their long-term memory. But having them teaching it is another story. So we have 9, and then this is 10. Notice that this looks the same, similar, but the only difference is the place value. So if we look, we have our 1s, our 10s. So this is 10. We have 100. We have 1,000, and then we have 10,000. Ah, yes, very. I'm okay with it too. I guess I would be able to understand if you are. Yeah. Oh, somebody said I'm trying to make Abacus public friendly. Public friendly, I think it was called. So, but yeah, I want Abacus to be really popular because there's everything else under the sun that's really popular, and I think it's just I guess I will be the advocate for the Abacus. So. We're going to count. So if we understand how to count, we're going to continue on because I'm going to start going into how to make a 9, how to make a 10. Are we okay with that? So it should be when we talk about how to make a 10, we know how to make a 10. Some of the things to do would be 9 plus 1 is equal to 10. And then what else do we have? What other numbers can we use to make a 10? The reason why is because we're going to utilize this other column. We're going to make our numbers work for us. We're going to utilize this column. So when we utilize this column, we need to figure out how to make a 10. So it'd probably be it'll probably help a lot of kids. Yeah, and you know what? To tell you the truth, it starts with you guys, right? Because you guys are on my lives and you guys are learning. Thank you. Because you guys are learning, hopefully you guys can teach your children, and that's the whole plan. That's the whole point, right? The whole goal is to try to spread the word. And if you guys can learn it and teach your kids or your nieces and nephews or your cousins or what have you, I just funny, my kids' friends came on board. So my kid is 13, and his friends actually came to my lives and they were interested, so he had to teach them how to do the abacus. And I'm like, that's fantastic. So that's great. Right? I told my friends that I'm learning. That's fantastic. That's fantastic. And you just keep learning it. You just keep practicing. And so what we're going to do is we're going to just keep reviewing how to make a 10. Right? Were they interested? It's a different thing. I mean, some people would be like, well, why are you learning how to add and subtract? It's not about adding and subtracting. It's about using this as brain gymnastics. Like, why do we do Sudoku? Right? 7 plus 3. Thank you. 7 plus 3 is equal to 10. We did 6, we did need to do 8 plus 2 is equal to 10. So I think we got everything, right? We got everything. Yeah. Yeah, we were. Okay, yeah. That's fantastic. I would start them slow, right? Tell them how to count it, how to use it. Then afterwards, you start to showing how to, you talk about bead recognition. And after bead recognition, then you can start doing simple adding. So just as I showed you, simple adding is 5 plus 2. But this is not 5 plus 2. This is 500 plus 200 is 700. And that's crazy, right? That's really crazy. But it doesn't matter what column you're in. And that's the greatest thing. The greatest thing about abacus, it doesn't matter what column you're in, because the abacus tracks your columns. So here we have it. And then again, what we're going to do is we're going to isolate the variable. The variable we're going to isolate is, let's do 7. Let's do 7. So again, just to remind us, we're going to isolate the 7. It looks very familiar, doesn't it? Doesn't it look like algebra when I do this? Is equal to 10. Doesn't that look like algebra? Abacus is the gateway to complex math. I'm telling you. I'm telling you. Who says that? I'm telling you. There's a comedian that I like to follow. His name is Bob Marley. He's a white comedian from Maine, and his name is Bob Marley. And he's funny, but he's old people joke. Okay. So what's gonna happen is I gotta what did I say? I have to move this, right? I have to balance the equation. I have to isolate my variable, right? To isolate my variable, I do x is equal to plus the 10 minus the 3. Now we know how to do this. That's fine. So then if I replace the x, we know that it's 7 is equal to plus the 10 minus the 3. Now what happens? Well, what we're going to do is we're going to do 99. No, we do 9. So we do 9, and we're going to add the 10. I'm sorry, we're going to add 7. To add the 7, what do we do? What do we do? Add the 7. So I got to add 7. So to add 7, I need to, right, we need to plus the 3. We need to minus the 3 plus the 10. So if I line it up, the reason why I have this is to line it up. So if I have this, and I line up my little flippy thingy, right? I line it up. If you notice, the 10 is 1 and a 0. That's the 10. Does that make sense? The 3 comes in here. So I have to take away the 3. So I take away the 3 and I add the 10. I add my 1. See how I add the 1? So then my answer is 11. Yeah. This is actually very helpful. Thank you very much. Oh, yeah, not a problem, Dean. Yes, Beal, that's what it is. I always get confused with the letters in math. Yeah. Yeah, I don't. Abacus, this is the beginning parts. So I think if you start, playing around with this, you'll be able to understand more abacus. I'm sorry, algebra, because it's very common what we do. We isolate the variables and then we substitute the formula. Dean, this is actually so helpful. Oh, good. Yeah. So when I was looking at it, I was like, huh. And I was like, it kind of blew me away that if I just made it vertical and did it this way, it makes a lot of sense. And I was like, whoa, I never did it vertical before. I'm still learning. It's been 20 years and I'm still learning. It's because I'm trying to make it relatable. Thank you for the follow. Hello, Mama Bear. Okay, so do we understand how to read the abacus? If not, I'm going to continue. We learn something new every day. Yes, yes, yes. You're absolutely right. It's so funny. Like, I talk about abacus and I'm still learning. I'm still learning different ways to explain it and stuff. So we understand this, right? So the next thing we're going to do is we're going to do a two-step equation. Why? Because that's the next step, to do a two-step equation. But I do understand that maybe we do a 99. So the question was 99, right? The question was 99. So we do 99 and plus 7. So we did 9 before, and then we did 99. Again, we want to plus the 7. There's not enough beads to add the 7. So what do? We have 7. We don't have enough beads to add the 7. What do? We have to plus the 10 minus the 7, minus the 3. So again, I'm going to have to plus the 10 minus the 3. That's what I did here. Hey, Laura, how's it going? So what we're going to do is we're going to plus the minus the 3. So I'm going to minus the 3 so I don't forget. And then here, if you notice, I lined it up, plus the 10. But notice my 1, I don't have any beads, right? Because I'm going to plus the 10. I don't have any more beads to add the 10. So what do? Do you remember how to plus the 1? Can I plus the 5? No, I can't plus the 5 because I'm already using it. Oh, all good. Yeah, fantastic. So I already have the plus 5. So I cannot plus the 5. So what do? I have to go to the next column. But I'm not going to minus the 10. I'm not going to add the 10 minus the 3. What am I going to do? Do you remember how to add the 1? So what I got to do is I need to add the 1 here. Do I know how to add the 1? So plus the 1, right? Plus the 1 is equal to plus the 10 minus the 9. So that's the formula. So I got to find So that's what I'm going to do, plus the 9. So if I look at here, I'm going to plus the 9. I'm going to minus the 9, plus the 10. I cannot plus the 10. Why? Because I don't have another column. So I need to show another column. There we go. There's my other column. And then from here, I'm going to plus the 10, and then I'm going to take away the 9. So I'm going to take away the 9. Does that make sense? So we just did a two-step equation. My answer is 106. Right? Yeah. I just made this yesterday too. Because I noticed that people were getting confused. You know what? When my kid was going through it, he was getting confused too. And so I actually made a little contraption to just kind of cover up the columns, because it's just overwhelming. And I just messed this up. Oh, I think I got to do it this way. Yeah. I just started learning how to use an abacus a few days ago, but this helps. Oh, good. Oh, good. Were you learning it from me or from somebody else? Because I know there's a few other abacus teachers. But yeah, this is interesting. Like, I like this. I like this. Okay, so I got to figure this out. There we go. I don't know. Anyways, yeah. Okay, so that's what the two-step equation is. The reason why it's called a two-step equation is because this is another equation. Hello, Irina. Welcome back. Welcome back. I feel like it's just like, it's like a little reunion. So this is our two-step equation. Why? Because we need to do another thing here. This is what this is. That's why we had to do it. Oh my God. Hi. Aw. Thank you. Let's do another. I came in on the end of that one. Yeah. We're going to do another one. We're going to do another one. But this is the idea. So I was talking about like my little contraption. But the idea was to understand how to do these. Yeah, we're going to continue. We're going to... Oh, I see. Okay. Okay, there we go. Okay, got it. Okay, so let's do another one. Let's do another one. Okay, so again, what we're going to do is just to, we're doing the family. We call it family. Some people call it big friends. I'm calling it making a 10. Okay, so the reason why is because in math, in regular school, we always teach the kids how to make a 10. And this is where we start talking about carrying on. So we talk about carrying on, right? We also talk about borrowing. So this is the beginnings of borrowing. There's another one they call it. It's called grouping and regrouping. And then another thing they call it is trading. I think they're starting to use a word called trading, which is okay too. They're all the same. Why? Because we're all talking about the tens. We're always talking about how to make a 10. I remember all of these. Oh, yeah, right? I am old. We only talked about carrying and borrowing. When my kids were young, then they talked about regrouping. And then I'm hearing this new terminology called trading. I'm like, okay. But how do we do it on the abacus? All of this is being done, and it all depends on this 10. That's all it is. It all depends on the 10. Because if you notice, when we add the 10, that just means we're going to the next number. We're just going here. This is what carrying on means. It goes to the next number. So if we have another question, let's do 90. Let's do 98 plus 5. I had regrouping but not trading. Yeah. I have a student in my class right now, and the mom is like, they're doing trading. What does that mean? And I'm like, it's all the same. So here is the plus 5. When we do plus 5, what is the formula for plus the 5? We need to know it's plus the 5 is equal to plus the 10 minus 5. Laura, so I made a little chart thingy. It's about, okay, you know what? I'm just digressing. Okay, so what we're doing is here, 8. So we're going to do 90 and we're going to do 8. So I have 98 and then 98. And then what's going to happen is I'm so excited. I was just making more stuff. And so that's where this came along. So I actually made something like this for my child probably 8 years ago. So this little thing I made 8 years ago. I just made this last night, but the concept I was thinking about it. Anyways, so what we're going to do is we're going to add the 5. we're going to add the 5. Where are we going to add the 5? We're going to add the 5 here where the 8 is. Notice I don't have any beads to add the 5, right? I got to go clean. Thank you. Yeah, not a problem. It's cool. I'll see you later. I'll see you in my next live. Thank you for the follow. Thank you for commenting. This is fantastic. I do enjoy not being alone. So we want to add the 5. To add the 5, we know we have to plus the 10 minus the 5. So what's going to happen is we're going to plus the 10. So we got to plus the 10. So here's my little flippy thingy. There, plus the 10. So when we plus the 10, oh, you're back. Oh, yeah, okay, cool. So we have it. I'm going to make it vertical. This is horizontal right now. I'm going to make it vertical. So notice if I line it up, right, if I line it up, all I got to do is plus the 10. And now I have another column. Does that make sense? So what am I going to do? I'm going to plus the 10 minus the 5. Plus the 10 minus the 5. I'm going to plus the 10 minus the 5. I'm going to take away the 5 so I don't forget. And now I need to plus the 10. I cannot plus the 10. So what do? I have to find how to add a 10. How do I add the 10? Can I add the 5? No, I can't add the 5. So what do? Plus 1. Yes, exactly. Plus 1 is equal to plus the 10 minus the 9. This is a formula that we need to know, right? This is the same formula as up here, right? The same concept. Yes, thank you, Bill. So that's what it is. I'm going to plus the 10 minus the 9. So what's going to happen is I'm going to plus the 10. When I line it up, I got to go to the next column. So I'm going to move it over. And there I am. So I plus the 10. And I take away the 9. So I'm going to plus the 10, take away the 9. So when I move my stuff off, hopefully it's the same. So then my answer is 103. Yes, right? So that makes sense. So sometimes it's just easier to isolate the columns that we're working with. We only work with 2 columns at a time. Oh yeah, 104. Thank you. No, 3, because it's 98. It's 98. That's the reason why sometimes I use this, because we want to isolate the columns. When we isolate the columns, sometimes too many columns, it gets overwhelming. So that's why I made this little contraption thing, right? Make sense? So when we look at it, it's either here or it's here. We don't need to look at anything else. Those are the only 2 columns we need to look at. It doesn't matter which 2 columns. Funny, right? It doesn't even matter which 2 columns. Because we can make this like super long. And it'd be the same thing. Let's do, I don't know, right? We do 9, 9, 9, 9 plus 4? Do we want to do that? Plus 4? Same thing. Same thing. So 9, 9, 9, 9 plus 4. I know, Beal, we did this, right? We did this. Now we're going to add the 4. We cannot add the 4, right? We're adding the 4 here. When we add the 4, can't add the 4. What do? Oh, thank you so much for the hand heart. Oh, thank you so much for the hand heart. We're going to add the 4. We're going to add the 4. How do we add the 4? Oh, minus the 6. Okay, when we do it, right, the question is I want to add the 4. When we add the 4, is there enough? Thank you so much for the hand heart, Beal. So when we add the 4, there's not enough. What do? We minus the 6 plus the 10. So I'm going to minus the 6 first so I don't forget, right? And then we plus the 10. Notice, I'm trying to line it up. When I line it up, I'm doing this. I want to plus the 10. Do you remember? We did it yesterday. Yeah, we did, right? We did do it yesterday. So then the idea was we want to plus the 10. Notice we want to plus the 10. So when we plus the 10, remember, so now I'm going to close this up. I want to go here, plus the 10. When we do the plus the 10, it's plus the 1 minus, because notice I want to plus the 10. Plussing the 10 is like plussing the 1. It's like plussing the 1. When we plus the 1, right? Oh, maybe I should figure that one out. So we don't have enough beads. What do? Well, we got to plus the 10 minus the 9. So again, I got to plus the 10 and go to the next column. So I'm going to minus the 9, and I need to plus the 10. Can't do it, so I'm going to roll it over. And I'm going to minus the 9 again, plus the 10. Can't do it. I do it again. So I plus the 10 minus the 9. And now I'm done because I've already minus the 10. I've already added the 10. So when I slowly take it off, right, that's my answer. 10,000, 10,003. Yeah. Yeah, this was a really good one. I like the concept because I like it how we know that we're doing the same thing. And that's the thing. Oh, that was the other thing. So let's do 49. Okay, let's change it up a little bit. Let's do 49 plus, I don't know. Let's do 4. Let's do that. Let's do that again. So this time it's different. Why is it different? Because we're still doing a two-step equation. When we do a two-step equation, this is what we're doing. We want to add the 4. When we add the 4, there's not enough beads to add the 4. So what do we do to add the 4? What do we do to add the 4? To add the 4 is plus the 10 minus the 6. We've done that, right? If I want to add the 4, so it's plus the 10 minus the 6. So we plus the 10 and we take away the 6. Let me take away the 6 so I don't forget. But we're going to plus the 10. Notice, now I don't have enough beads to add the 1 because I have a 4 here. I don't have enough beads to add the 1. So what can I do? I don't need to do a plus 10. Why? Because that's too much. What's the next lesson? What's the next step? What's the next step in our framework? The next step is the plus 5. Yes, thank you, Laura. Plus 5. So what's going to happen is if I want to plus the 1, I need to, if I want to plus the 1, what do? If I line it up, I plus the 5, take away the 4. When I line it up, I pretend, I didn't want to put a line here because I didn't want to make it look like a fraction. But the idea was to remind us that we plus the 5 and we take away the 4. So when I take this away, my answer is 53. This is a two-step equation. Why is it a two-step equation? Because this 4 was plus 4 is equal to plus the 10 minus 6. And then we had to take this and we had to do plus 1 is equal to plus 5 minus 4. So we substituted this into here. Does that make sense? This is a two-step equation, and it gets more, right? Depending on how all of the words, hello, April, welcome back. So depending on what our numbers are, depends on if we have enough beads. So that's why this is called a two-step equation. And there's more than just, I mean, the two-step equation is a concept, but it also happens in algebra. Algebra also has two-step equations. It's just in Abacus we start to introduce the concept of understanding that there's more ways to add. So I hope you're doing well, April. Yeah, we were just talking about adding, and we're just talking about adding. We didn't do subtraction, but it's the same thing. It's just backwards. So sometimes it's just easier to explain it as a plus before we explain it as a minus. So, okay, Beal, did that make sense? We're all right? Do you want to do another one? We can do another one. We can do another two-step. But see, the thing is, you can only do either adding of a 5 or adding of a 10. You don't do any others. How do we know? Because if we did this one, okay, let's do this one. Here, let's do another one. It gets complicated, but we have to really understand it, right? So what does that mean? Well, let's do this one. 47. We do 47 plus 7. Why is this complicated? Because now it's like a two-step within a two-step within a two-step. So, again, we don't memorize our doubles. What we do know is we know our plus 10s. So we have 47, right? 47. this is where it gets a little complicated. Why? Because we want to add the 7. To add the 7, there's not enough. We want to plus the 7 is equal to plus the 10 minus the 3, right? We understand this. So we're going to plus the 10 minus the 3 plus the 10. This, this we cannot. We did this, right? We cannot add. We have to plus the 1 is equal to plus the 5 minus 4. So we plus the 5 and take away the 4. Now what do we do? Well, can we take away the 3? No, we can't take away the 3. So what do? We know if we minus the 3, it's equal to what? Minus the 3 is minus the 5 plus 2. So minus the 5 plus 2. I don't know what this is called. Is this a 2-step? This is a 3-step. This is a 3-step. This is a 3-step equation. So my answer is 54. Did that make sense? But see, the thing is we all break it down to how do we do a 5? Or how do we do a 10? Is that too much? Was that okay? Okay with that? We can do another one. But yeah, this is a 2-step within a 2-step. And it's just interesting on how numbers get. Thank you for the follow. Do another one, please. Okay, yeah, let's do another one. But it made sense, yeah? Did it make sense? Like, was it slow enough? Not slow, yeah, right? I don't want to be too fast because I know I talk really fast. So here's another one. Okay, here's another one. 48 plus 6. So I'm going to put 48. So I do 40, and I do 8. Right? We did that. That's not a problem, right? Make sense? So now we plus the 6. Well, do we have enough to add the 6? No. We do not have enough to plus the 6. I'm going to keep track of my colors. So, right? So I'm going to plus the 6. Plus 6 is equal to plus 10 minus 4. Plus the 10 minus the 4. Now what do? We want to plus the 10. So if I'm adding the 6, there's not enough. So I need to plus the 10 minus the 4. Does that make sense? I have to plus the 10 here. I cannot plus the 10. What's another way to plus the 10? Well, right, we talked about what does that mean? Well, we want to add a 10. If I line it up, I want to add the 10. Right? I'm adding a 1. That's what that means. I'm adding 1. So I have a 0 and I have a 1. I'm trying to add 1 here. So I'm back to here, adding a 1. How to add a 1? Well, to add a 1, plus 1 is equal to plus 5 minus 4. And then, so I'm going to add my 1. I'm going to add my 5, take away my 4. I still need to minus the 4. Can I do it? No, I can't. So this is where I have to break it up. Minus the 4, how do I do it? Minus the 4 is equal to minus the 5 plus 1. Yeah. So minus the 5 plus the 1. So then my answer is 54. Yes. Minus the 5 plus the 1. Yeah. That's where I was lost. Yeah. See, this is now a 3-step equation. Why is it 3-step? Because we have to go one within the other. But it still goes back to, just so you know, it still goes back to, do you have enough beads? Right? Do you have enough beads? If not, how do I get there? And so this is where you start getting flexibility. This is where you start seeing how the numbers become flexible. It doesn't matter how things are working. So you notice when I say, okay, you know what, let me take away the 4, or let me take away the 4 first, but I can't. So yeah, so that's what this is. And so this is another way of doing abacus. I mean, you could do it this way, you could do it other ways, right? I'm just showing you the abacus way. This is what we do in abacus. So this is where the brain gymnastics happen, because we need to see if we have enough. If we don't have enough, how can we do it? Again, when I see it, right? If I see it, I'm going to plus the 10. I know I'm going to plus the 5 minus the 4. I know I'm going to do this because I have it in my brain. This is already common. This is very ingrained into me. So when I want to take away the 4, I know if I want to take away the 4, all I got to do is minus the 5 plus the 1. So this is again ingrained. The reason why it's complicated right now is because you guys are still learning it. This is a plus 5 formula, right? This is a making of a 5 formula. That's why making of a 5 is very critical to understanding how to use it. When you get this become more ingrained, then it becomes easier as you practice it. So then it doesn't matter what column you're in or what you're trying to do, because it all boils down to making a 5 or making a 10. That's it. And it's crazy. It's so crazy. But it's exactly what it is. So what we did here is we borrowed. No, we did a carrying on. We did carrying on because that's what a plus 10 is. Plus 10 just means add another 5, add another 1. So if we did this traditionally, we would do like 14, right? 14 plus 1, and then plus 1 would be 1 plus 5. So that's what carrying on is. But what we do it in Abacus is we say plus 10 or minus 10. Yeah, not a problem. Let me know if you have any questions. So we can do borrowing. So how do we borrow? It's the same thing, but it's the opposite. Borrowing is the same, but opposite. What does that mean? Well, we have the 6, right? We want to do 6. It's just minus the 6 is equal to minus the 10 plus the 4. See how it's the same but different? All we're doing is just changing the operation. That's all we're doing. So if we do a minus 6, let's do 14 take away 6. 14 take away 6. So I do 14 and I take away 6. I don't have enough beats to take away the 6. So what do? This is where I borrow, right? I take 1 from the answer. Take 10 minus the 10 and then I plus the 4. Remember how to plus the 4? When we plus the 4, we know how to plus the 4, right? Plus the 4 is equal to plus the 5 minus the 1. Plus the 5 minus the 1. And my answer is 8. Yes. Thank you, April. Yes. Makes sense? So they're all interchangeable. You just need to know it like the back of your hand, right? Just like how we know our, the multiplication fact. So this would be the fact family. I think they call it addition fact family and subtraction fact family. That's what it is. Fact families. So what we did here is we understand the fact families. These are the fact families, right? We only need to know this. We don't need to know any other combination except for this. I wish you had a complete bundle for sale. I will, but not yet. Hello, Tech Druid. But for what age? I guess that's the other question, right? For what age? I'm still building it out just because I wanted to make it engaging. I'm in the process of making it really mainstream math. That's why. So, Tech Druid, preschool to teen. Yeah, I'm starting with the building out my other questions, my other things. So that's why I have it here, and then this would be the bundle. This would be like, whoops. So it'd be something like this. Oh, not like that. It would be something like this. But then I have a few more. I have to fit in a few more books, and then I'll be able to. Then it'll be more complete. But for right now, I'm still building it out. How much time do I need to master Abacus? Because I have a math exam after 2 months. Calculators are not allowed. It depends on how often you want to practice it. To master it, for adding and subtracting, you can master it right now. It's really, the concepts are not that difficult. You just got to practice it. So, I've told you everything. If you really think about it, I've told you everything. There's nothing to hide. It's just practicing it and understanding how to use it. So the biggest question is can I do it? If not, what can I do? So can you do it in 2 months? Yeah. Are you talking about multiplication and division? Then it's a little bit more. But if you're just talking about adding and subtracting, then it's, in a couple of weeks you should be able to be done. Right? And then just trying to figure out, our 2-step equations or 3-step equations. But this is just the fundamentals. It's just how do you fit it all in, like Tetris. Abacus is like Tetris. That's what it is. Abacus is like knitting, right? It takes one You take one yarn, and depending on how you twist it, you can make anything out of it. It's the same thing. You have your fundamentals. So you have your plus the tens, salwa. So I'm saying is you have your plus tens, your plus fives, your minus the five. Oh, where is it? Minus the fives, and then you have your minus tens. So these are the fundamentals. If you know this backwards and forwards, you will be able to add and subtract no matter what. I already know how to add. I need to learn multiply and divide. That's a little bit more complicated. Why? Because add multiplication's easy, because we can do that right now, and I'll show you how to do it. A multiplication's easy, but division's a little bit harder. Sorry for drilling for a moment. Did you have new charts? Did you have new charts? Oh, are you talking about this? The little Fitbit thingy? Is there an app you would recommend to train? I would just look it up. There's a bunch of Abacus applications for the iPhones and stuff, or for Android. But I think you have to pay for it if you want some higher. If you want higher. When you say new charts, Laura, what are you talking about? Like these little flippy thingies? No, you were gonna show me something. Oh! No, this was part of the book. This was part of my book. So this was about like the adding of the making of the tent. So this was for more presentation, and it was kind of cool because I was able to break it down, and I was gonna add this as part of my book. Not the actual filling out, because this was more presentation, but the idea was that if we're adding a four, how do we need to know that we need to plus the 1 is equal to plus 5, and that's it. That's all it was. And then the idea was like, how do I make a 4? I need to make the 4 by itself. So what I need to do is I need to take the 1, right? I have this, and I need to take it over here. So then that means I'm going to rewrite my question. So it looks like this, right? 4 is equal to 4 plus 1 minus 1 equals to 5 minus 1. So I'm going to rewrite the question, rewrite the formula, and I'll do 4 is equal to plus 5 minus 1. And then this is what we call commutative property, where it doesn't matter what order the numbers are, as long as it happens. And so this was actually this was going to be part of the adult book. Because this one's, the kids don't care. The kids don't care about isolating the variable. So this was more for the adults. And so I made one for the adding, and I was working on the subtraction one. So this is not a chart for the kids. This was just something for me to present. And I thought this was really cool. I was really excited. Just like my little flippy thingies. I was excited for those. And then my isolating chart. And then I was gonna do what I wanted to do is I'm gonna make this a printable, but you just have to get really good paper. But yeah, I mean, you could do it. Could I get a copy of this? Yeah, you could get a copy. Yeah. I made a 5. Oh yeah, that's good, right? The kids enjoy it. Oh, did you make it this way or did you make it this way? Oh, and then when you do it, sometimes it's easier if you do it vertical, right? You can do it vertical, so then it reminds you. If I wanted to plus the 1, you can plus the 5 and then minus the 4. So if you look, I made it vertical so it reminds you. Yeah, that way. Oh yeah. Instead, a printable 3D print a tool. I don't even know how to make that. Yeah. So, Laura, send me a DM asking of the copy for the utilizing the 5 bead. And yeah, I can send that over. But it's all going to be filled out. This is not filled out. It's all going to be filled out. It was like a little chart thingy. I was working on that as part of the book. Yeah. So, yeah, thank you. But yeah, it's called Utilize the 5 bead. And it's only, right now I have 4 pages. But yeah, when you do the flippy thingy, for the vertical, it's kind of cool. Instead of a printable, 3D print the tool. I would not even know. It's still helpful. Okay, good. I wouldn't even know how to 3D print this thing because I needed to slide. I don't know. I guess I could ask somebody, how would you 3D print this? But that's the thing. Yeah, that's an idea, to 3D print it. Okay. Okay. I'll see what I can do about that. Thank you, Tech Druid, for the advice. Advice? The comment? Yeah, advice. Yeah, that'd be good. That would be good to try to 3D print it. Yeah, okay. Yeah, not a problem. But it was going to be, yeah, it was, I was trying to break it up into like my different books. So I think, because I was trying to section them off depending on the ages. I'm still doing the ones for the young kids because I still need to finish that whole series out. But once I get the series done, then I can start going on to other ones. Yeah, I like to see small business succeed. Oh, yeah, I hope so. I hope this helps. I hope this works. I honestly hope this works because this is. I mean, I got my job. I got laid off. I got laid off on my job. I was a computer programmer, and I'm like, you know what? I kind of want to see what I could do with Abacus, and so I know that Abacus, not Abacus, but I know math is crucial, and the kids are not understanding what's going on, and I think that this is hopefully this will be this will work out. I hope this will work out for me. So that's the hope. If not, I'd have to find a job. Anyways, so but thank you, Tech Druid, for the recommendation. Okay, so we have the adding of the 5, adding of the 10. So this is the two-step equations. This is now three-step equation, right? Because we did 1, we did 2, and then we did 3. Yeah, thank you, sir. See you later, Laura. I'll talk to you later. I'll see you in my next live. Um, Beal, did this make sense, or do you want to do another one? Are we okay? And then Ruben, I think Ruben's still here. Haha, Beal, you're so kind. You're so kind, Beal. Very generous. Okay, do we want to do another question? Make sense? Yeah, it makes sense, right? Okay, good. So, do we want to do more adding and subtraction, or do you want to do what is it? What is it? Do you want to do bigger numbers, or do you want to do multiplication and division? Hello, Echo. Echo, echo, echo. Ah. So, some people that joined in, let me just let me just talk about how to read the abacus. So, what we're going to do is we're going to read the abacus. This is 1, 2, 3, 4. Whenever the beads are touching the horizontal bar, this is considered counted. So we have 4 and then 5. All the top bead is a value of 5. Because this is 5, we have 6. So we notice that when the beads are touching the horizontal bar, this is the horizontal bar, 6, 7, 8, 9. After 9, I know getting the basics is down good, but I kind of want to see multiplication. Yeah, we can do that right now. So this is 9, and then this is 10. Because this is 10, we have a 1 and a 0, just like how we have place values, right? Because of the place values, we have every column is a place value. So we could do ones, tens, hundred, thousands, 10,000. And then this would be 100. This is 1,000, and then this is 10,000. But yeah, no, let's do it. Let's do some multiplication. It's good. Okay, so one thing about multiplication is you need to know your multiplication fact. That's a hands down thing. And I teach the kids to do it cumulative addition. What does that mean? So that means that I have another thing where these are dinosaurs, and we talk about like adding a 3. So when we add the 3, we want to do 3 plus 3 plus 3 plus 3. So this is the foundation of what I want the kids to do. My kids learned it this way, and they got tired of it, so they started memorizing. So this, we do 3 plus 3. We know this. We do 3. I'm going to track it. So I'm going to use this to track 1. 1 times 3 is 3. 2 times 3, which means I'm going to add another 3. To add another 3, I need to plus the 5 minus the 2. So that's 6, right? I'm going to add another 3, right? All I got to do is make another 3 there. I think everything makes sense on the abacus but division. We'll go into division. Then we want to add another 3 to add, so this is 9. I'm just keeping a running total, right? I'm just keeping a running total so we know what we're seeing. So I want to add another 3. I need to plus the 3 is equal to plus the 10 minus the 7, right? Plus the 10 minus the 7. So my answer is 12, right? So we know that 3 times 4 is equal to 12. this is how we do it in Abacus. That's all it is. And so, I mean, it's just cumulative addition. However, we need to know our multiplication. We only need to know up to 9. 9 times 9. So if we know 9 times 3, we're golden. It doesn't matter. We don't need to know anything about that. Why? Because we can start talking about it. 3 times, let's do 24 times that by 9. So the first thing we need to do is we need to understand where are we going to put our number. We need to count our digits. To count our digits, we need to count 1, 2, 3. So we know we're going to be at the third column. Does that make sense? We know we're going to be at the third column. Does that make sense? Oh, are we okay, Ruben? Does that make sense? How do we know? Because we're counting the digits. When we're multiplying, we need to add our digits. When we divide, we need to subtract our digits. So when we're multiplying, will it always be like that? Yeah, it will always be like that. It doesn't even matter. If I gave you like a huge number like this, like 6, 7, 8, 9 times that by 4, 4, 3, 2, 1, you just count them all together. 1, 2, 3, 4, 5, 6, 7, 8. So that would be 8. Does that make sense? So it would be 8. I would have to use a bigger abacus because I can't do 8 here, right? So it'd be 1, 2, 3, 4, 5, 6. Nope, I got to start from here then. I'll start from here. So this is my ones. This is why knowing your dot indicator, right? Knowing your dot indicator helps, right? You can move wherever you want. So I need 8. 1, 2, 3, 4, 5, 6, 7, 8. So yeah, it will always be like that. In multiplication and division, it will always be like that. All right. So we're back to here. So we know that we're going to be in our hundreds column. 1, 2, 3. 1, 2, 3 in our 100 column. Then what do we do? Well, all we have to do is 9 times 2. That's it. 9 times 2. We know what 9 times 2 is. 9 times 2 is equal to 18. So I add my 1 and then my 8. 8. We're done. Are we done? No. We have to do one more. We do 9 times 4. 9 times 4 is 36. Add my 3, I add my 6. I add my 3, I add my 6. I add my 3. Do we remember how to add the 3? See, this is why it's critical to know your basics, right? But you would need to add your 3. How do you add the 3? Plus the 10 minus the 7, right? That's my 3. And then I need to add the 6. And that's it. That's my answer. My answer is, what's my answer? Two, we have the 1 here. 216. Yep. 216. Yep. Makes sense, right? So this is why we need to know. You will get to know your basics. You just always know that when we add the 3, you got to plus the 10 minus the 7. So again, we utilize it. So it's not difficult. It's just another step. We can do another multiplication. Do you want to do another multiplication, or do you want to do division? We can do another multiplication. Excuse me. Wow, 7,000 likes. Tech Druid, is there any question? Do you want to do division or multiplication? I only see there's 7, but I only see three names. Oh, Whoops here. And Joe. Okay, multiplication, more multiplication. Okay, let's do it. So we can do let's do this one. Yeah. Multiplication. The biggest thing is understanding how to multiply, right? The biggest thing is understanding. That's all it is. It's just your multiplication fact. Hello, Ruben Garcia. I see another Ruben. All right. So we're going to start from here. We'll start from here. Okay. So let's do, 69 times that by 7. Same thing. What are we doing? We got to count. 1, 2, 3. 1, 2, 3. Right? That's all it is. So then we do what? 7 times 6. See, okay, so the difference is in Abacus, we do 7 times 6. We do 7 times 6. That's what we do in Abacus. In New Math, they say 7 times 60. And then they get 420. But you look, here I just say 42. All I got to do is add 4 and add 2. Why? Because Abacus keeps track of my place values. I don't need to do this. All I got to do, right? All I got to do is this. 42. I add 4, I add 2. And then what's next? I do 7 times 9. 7 times 9 is 63. Add my 60, I add my 3. I add 6, and then I add 3. That's it. Bam. Was that easy, Ruben? That was pretty easy. See, you didn't even need to know, need to know the basics because it's all there. You just needed to know your multiplication fact. So what is my answer? What is my answer? My answer is 483. Yes, 483. 408. 5, 6, 7, 8. 83. Oops. Does that make sense? We can do another one. We can do, okay, we'll do this one. We'll do 28 times that by 8. How about that? Again, what are we going to do? Same thing. 1, 2, 3. How do I know? 1, 2, 3. So what's going to happen? Eight times 2 is equal to 16. I add 1. I add 6. And then what? 8 times 8 is 64. Is that right? 64. So I add 6, I add 4, I add 6. I can't add 6. This is where our basics come in, right? How do I plus the 6? Plus the 6 is equal to plus the 10 minus 4. I plus the 10, I take away the 4. Can I take away the 4? Nope. Again, what do? Minus the 4 is minus the 5 plus 1. Minus the 5 plus the 1. And then plus the 4. So my answer is... What is my answer? So that's what we did. We did another 3-step. We did 6, and then 6, and then we did 4. I'm sorry, 6 and then 4. No, we did, this is a 2-step. This is a 2-step. 224. Yes, 224. Let's do times that by 9. So what happens? Okay. 3. 1, 2, 3. 1, 2, 3. 9 times 5 is equal to 45. I add 4. I add 5. I do it again. I did this, and I did this. Add 4, add 5. That's the easiest number. That was the easiest question. What's my answer? Yep, 495. Yep, 495. But it's all because I can see it on the abacus. I know I can just add 45, and I can add it again, 45. So can I see it? Yeah, I can see it. Because I know, I think for my head, I can only see like 3, maybe 4 columns. I don't think I can do more than that. Like me specifically. But, other people can. I just don't. We could do this one. Let's do this one. Oops. We do this one. Oh, excuse me. I've got to change colors. Let's change colors. Let's do 73 times that by 7. Same thing. Thank you, Ruben. Thank you, Bill. Same thing. 1, 2, 3. My son wants to go play outside, so I'm going to go. Yeah, not a problem. I'll see you later. I've watched you briefly these past few days. You're a great teacher. Oh, thank you, Mama Bear. I'll see you later, Ruben. Have fun. Yeah, thank you, Mama Bear. I hope I am. I appreciate that. There's not too many there's not too many what? I don't know. I don't know what to say. Thank you so much. I appreciate that. Okay, so Beal, we're gonna do another one. We're gonna do multiplication. Mama Bear, do you know how to count on the abacus? I mean, you've seen. I just want to make sure you know how to count on the abacus and what we're doing. So what we're doing is we're doing multiplication. So the columns that we're going to start off is going to be the third column. Yes, from you. Oh, okay. Okay. Because some people are really like, I don't know, I'm so confused. But no, I understand. Thank you. Okay, good. So what we're going to do is we're going to do multiplication. We're going to start from the third column. How do I know? 1, 2, 3. So what's going to happen? What's my question that I'm going to do? I have to go. See you later. Thank you, Tech Druid. I can't wait for my abacus to come in. Yeah, you got your tracking number, right? I don't know where it is right now. You should get it pretty soon. So 7 times 7 is 49. So I had 4 and I had 9. Oh, this is going to be fantastic. Why? Because now we're going to start doing our 2. Oh, you just got it in the mail. Oh, yeah. You just got an email. Yeah. Good. So then 7 times 3, after that, right? 7 times 3 is equal to 21. So I sent it out yesterday. So we're going to add 20, we're going to add 1. Add the 2. We cannot add the 2. What do? Can't add the 2. So we plus the 10 minus the 8. So plus the 10 minus the 8. Plus the 10 minus the 8. Notice I could do plus 2 is equal to minus the 8 plus the 10. This is why we call cumulative. Cumulative property. Why? Because I can have it any which way to make it equal to plus 2. Why does this matter? Because I don't want to forget. I don't want to forget to take away the 8. So let me take away the 8 right now. And then what I want to do is I need to add the 10. Because I add the 10, how do I add it? Can I add 1? No, I can't add the 1. So what do? Can I add the 5? Plus the 1 is equal to plus the 5 minus 4. So I'm going to plus the 5, take away the 4. So that I'm done with that? No, I still need to do the 1. Because what we did is we kind of went down, it's not a rabbit hole. This is not a rabbit hole. This, right, is this, which is that. That's not a rabbit hole. But we need to do the 1. So we need to add the 1. So my answer is 511. 511. Right. Mama Bear, do you have any questions? We're just doing multiplication, but yeah, do you have any specific questions, like how I did like certain 2-step equations or what have you? I have to go. Thanks for all the explanation. Yeah, I'll see you next live. I see you in my next live. Whoop, 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 whoop. It was good to see you. Thank you for helping communicate and comment. Yes, not currently. I enjoy watching and learning. Oh, okay. 288. So, okay. Yeah, it's just interesting, like the path and stuff. But this one I really like the concept because I do this quite often. I do exchanging of the 2, and I like that. So, it was interesting. The actual how to do it. Do you remember which column are the amount specific? Do you remember which columns are the specific amount. Yeah, that was new. What do you mean, Dean? Do I remember which column are specific? Like where my place values are? It helped when you had the labels. Yeah, okay. Do you remember? How do you remember which column? Oh, I the first thing I do is I know where my indicator that I use. I always use this. I try to use this indicator. The indicator is this little black dot that's on my horizontal bar. So I know that this is my ones, but I know my numbers, right? So we know our place values just as we write in regular math. This is my ones, my tens, my hundreds, my thousands. But when I'm going through it, I don't pay attention to the columns. I pay attention to the specific column. So here, that's why I have my little contraption. So I have my little contraption. If I do 49, I know I'm going to start at 3. 1, 2, 3. I'm going to do 40. I'm going to do 9. So I'm going to extend it, right? So I need to know 40 and then 9, right? So then after that, what happens? Well, I need to do 7 times 3. So 7 times 3 is 20. So I have to do 21. I do 20. I do 1. 21. But to do 20, I don't have enough. So this is where it's always around the neighbors, right? So I think what it is they're always neighbors. It never goes further. It never goes to up here. You always look at the specific next column, if that makes sense. So when I look at it, I want to add the 2. I cannot add the 2. So what do? I plus the 10 minus the 8. I'm going to take away the 8 so I don't forget. I'm going to add the 1, right? I know I'm going to plus the 10. Plus the 10 is plus the 5 minus the 4. So this is my 2. Now I have to do 1 out of 21. So I add the 1. So notice it's always going to be right around these columns. Does that make sense, Dean? So when I look at it, I'm only looking at specific columns, either this one or this one. Oh, that makes so much sense because I got confused thinking they were all ones. Yeah, yeah. No, no, no. So then when you take a step back, they are just ones, but when you take a step back, then you can look at the whole picture, if that makes sense. So that's why I use this little thing to help me. Yeah, that's what we're doing. No, you're absolutely right. They are all ones if you think about it. So if I add 40, let's do 49 again, right? We do 49. We have 2. We're going to add 2. To add the 2, it's always going to be one column over. That's it. It's always going to be one column over. So no matter what, always be one column over. No matter what. It will never be 3 columns. It will never be 3 columns. It will never be 4 columns. Oh, it helps. Probably I just need the labels to help. Yeah, yeah. Oh, the labels. Yeah. Sometimes the labels help. Sometimes isolating the columns help too. So my kid had a problem with too many columns. So I would have to just say, okay, what are we doing here? And then I would extend it. Okay, this is what we're doing. So sometimes it helps to just see the specific columns. That's why I have different contraptions. I just enjoy trying to make it easier for people to see. I really like how it's simple it is, but if you don't understand what you're looking at, it can get confusing really quick. Being overwhelming is, it's easy to be overwhelmed. Right. So yeah, so when you add the 49, right, it'd be like that. Add the 20 and then add the 1. Add 20, add 1. Yeah. So, yeah. Any other questions? Oh, oh, that does get simpler. I just thought I don't. Yeah, yeah. Yeah. But we teach the children to overthink. I think that's why we have all these strategies and all these variations in our head. But really, it just boils down to just the one thing. And then when you're done with the one step, it's like just focus on your next task, right? Focus on what you're trying to do and then step back a little bit. So it's a lot about just what's in front of you and then you move forward. And I think that's what we do. I think we teach the kids to, like in early on. I mean, later on it'd be fine to don't overthink, but later on to get all of it. Anyways, but yeah, I think what we do with the children right now is we tell them there's too many things. Like like we do 500, right? 500 is these squares. So we start drawing it out. 1, 2, 3, 4, 5, right? And then we have one, and then we have one dot. And so I think it gets confusing really quick because that's a lot, right? So what Abacus does is we simplify. We only need to know what 7 times 4 is. We don't need to know 70 times 7. We don't need to know that. That's complex, right? What Abacus does is it strips away the complexities. We know our multiplication table. We know our multiplication table. It's 7 times 7, not 70 times 7. We don't learn it that way. So, yeah. Yeah, not a problem. Do we want to do we want to continue on with more multiplication? Those are really good questions. Okay. Yes, please. More multiplication. Okay, not a problem, not a problem. So I'm going to change to another page. Change to another page. Another page. Anyways, okay. So these ones are, whoop, whoop. Okay. So these ones are, we'll do something with the fives because fives is nice. I like fives. Fives makes it easy, right? 5 times 5, 75 times 7, 75 times 5. Again, what are we going to do? We're going to count. 1, 2, 3. So we're going to count. 1, 2, 3. The first thing we're going to do is this. 7 times 5 is 35. I add a 3, and then I add the 5. This is the last column that I'm touching, so I stay here. So my next question is 5 times 5. 5 times 5 is 25. I add 2, and then I add the 5. That's it. So what's my answer? That was easy. Wow. Thank you guys so much for liking the live. I have 8,000 likes, man. That's cool. And I see a Pisces? I think I see Pisces. I'm not sure what I see. The answer is 370,567,5. I'm pretty sure. Oh, that was actually so simple. I'm pretty sure. Yeah. 375. Oh, I missed that one. Yeah. Yep. Okay, let's do another one. Let's do 83, 87 times that by 3. So, again, 1, 2, 3. So, we do 1, 2, 3. See, and that's the thing. Like, what we're doing is we're just moving the beads. So, are the blue? Yes. The blue ones are always, actually, it's not blue. It's the top bead. The top bead is always a value of 5, no matter what. The top bead will always be a value of 5. So this is 5. This is all 5 because it's all touching the horizontal bar. So if I did this, nothing, right? This is 0. So when I count 5, 5, this is 55. This is not 10. This is 55. This is 10. How do I know? Because this is my dot indicator. My dot indicator is my ones. So I have my ones, just as I had here. Same thing. My ones, my tens, my hundreds, my thousands, my 10,000. But because I have more columns, I can have more digits. I can have more place values. I can have more digits. That's what it is, really. So my ones, my tens, my hundreds, my thousands, my 10,000s. And then my millions, I have millions up here. So then when I look at it, that's why there's these indicators. The indicators are also separators. They group them for me. So I know that this is my thousands, and then this is my millions. So what's going to happen? Like if I started here, so pass the dot. Yes, exactly. So after this, right, on the right side, this would be my decimals. But if I chose this to be my ones, then I have all of this number. I have 13 columns to be my answer. 13 columns, right? Ones, thousands, millions, billions, and then trillions. Does that make sense? So the dot indicator helps to label the grouping, just as we have it in when we write. So I have 3, 1, 2, 3, right? That's 30,000. That's 3,000. 1, 2, 3. This is 3 million, and then 1, 2, 3. This is 3 billion, right? So every comma is a group separator. So this is my thousands, millions, billions, trillions. 1, 2, 3. So I need one more. Learning as an adult. Yes. Yes. It helps a lot knowing which ones are the different values. Yes. Yeah, it's all about but it all depends on your which one you indicate. Which dot do you indicate? Which dot is going to be your ones? Which dot is going to be your home? When you can select any one of these dots. This dot is not a decimal because decimals do not happen on a place value, right? It happens between the place value. So yeah. But again, the top bead, I try to say top bead, not the blue bead, because when you have an abacus that does not have color, then it doesn't make sense, right? So that's why I always say top bead. The top bead is the value of 5, no matter what. All the top bead is a value of 5. So we have 5, 6, 7, 8, 9, and then this is 10. This is 10, 10, 20, 30, 40, and then this is 50. Because this is 50, I can do 60. This is 65. So 60, 5, 6, and then 5. And then this is 565. 565. Yeah. Learning as an adult. Yep. I learned abacus as an adult as well. Am I fast? I'm not as fast as my kids. My kids know them, but they also but they don't teach, so they don't remember what the formulas are. But if you give them an abacus, they'll know how to use it. They'll remember. It's like riding a bike. Once you learn it, it's like riding a bike. Because why? It's also about what? The questions you ask. So the biggest questions will be like, do I have enough? If not, how else can I do it? And knowing the formulas, you'll know how to maneuver around. Like if I have 4 plus another 4, can I add? What do? I have to plus the 5 minus the 1. That's a formula. That's something that we need to know because we're utilizing our 5s. Yeah. Oh, so we're here. Sorry, we're here. I have to go. Yeah, not a problem, Dean. I'll see you later. Thank you so much for liking the live, Mama Bear. Yeah, I'll see you in my next live, Dean. But yeah, come with questions. Even if you're like math questions, come with math questions. Hopefully they're arithmetic. I don't know calculus, and I don't know algebra. I don't know trigonometry too. Hope to see you tomorrow. Have an amazing day. Yeah, you too, Dean. Have a great day. Have a great day. All right, so we're going to do this last one, and then I'm going to sign off if that's okay. So what we're going to do is we're going to do it again. 1, 2, 3. What are we doing? We are counting our digits. 1, 2, 3. So we have 1, 2, 3. When we do it, we're going to do 8 times 3. 8 times 3 is equal to 24. So when we have 24, we have 2 and we have 4. Oh, yay, he passed. Oh, my kid just passed his driving test. So now we have another driver on the road. Okay, so what's next? 7 times 3. 7 times 3 is equal to 21. So now this is where we do 21. Congratulations. I'll let him know. So plus 2 plus 1 plus 20 plus 1. Because of 20, do we have enough beads? That's where we need to know our... thank you so much, Mama Bear. Oh, thank you for the heart puff. Thank you for the heart puff. Liv Von Carr. We know this. We want to add the 2. Do you remember how to add the 2? Add the 2. I'm sorry. 2 is equal to plus the 5 minus the 3. This is a basic that we need to know. This is one of the fundamental pillars. I would say fundamental pillar. I would say though, a fundamental pillar that we need to know. So it's plus the 5 minus the 3. And then we add the 1. And then add the 1. So my answer is, what's my answer? Thank you, Beal. Yes. Yes, that's what it is. Right. Right? Makes sense, right? Like this pillar makes sense. So what's my answer? 261. Yes. Good. 261. That's my answer. Wow. There's still 8 people here. All right. Does anybody else have any more questions? It just clicked. Right? It sounded like it really clicked. I don't know what's the benefit in the long run of learning this, Vera. I enrolled my 5-year-old. Should I enroll my 5-year-old to this? I'm debating if I should. She shows interest. I would. Vero. Okay, so what's the benefit? The benefit is that the kids will understand, have a stronger sense of numbers. So there's number sense, number flexibility. It's the whole thing, right? Number sense, number flexibility, number understanding, right? And so the one thing is that the reason why I have 3 boys and I teach abacus. I teach abacus. I've been teaching abacus for 20 years, 20 plus years. One of the things is that it's concrete. So a lot of the problems is we teach the kids abstract. These are considered abstract. Hello, I just got here. I have no idea how abacus works. Hello, Perez. Let me talk about the benefits of the abacus. So Vero, there's a few things to know. So there's a lot of things that in school we're teaching the kids. We're teaching the kids about other manipulatives. So there's these blocks that we teach to the kids, right? This is great. This is fine. Now, why is this one of the things? Well, one of the things is because we're starting to try to get the kids to visualize the amount, right? So Perez, before let me finish my thought, and then I'll show you how an abacus works. So, Vero, when we start looking at it, now the idea is we start talking about trading, and again, it's another concept, right? So we have 10. We need to make 10. What did I just 6? 6. So what I had to do is I have to make a 10. So I have to take this, and this is a 10 block. This is a 10 thing. So now we get to a point where we have to count it, and I did it wrong. So this is what, okay, that's 10. So we go to trade it in. So we teach the kids all of these things, but there's no place values here. So then the question is well, how do you teach the kids place values? So now we're going into abstract. And then it gets kind of confusing. Whereas in the abacus, you see the abstract, you see how it all works. So, Perez, if you want to take a look, this is how we count on the abacus. We do 1, 2, 3, 4. Anytime the beads are touching the horizontal bar, this is being counted. Because this is being counted, this is 4. The top bead will always has a value of 5, no matter what. It will always have a value of 5. Because it has a value of 5, now we can start counting on. We can do 5, 6, 7, 8, 9. After 9, we have 10. So what we did is we actually using our place values. Every column is a place value. Because the place value is here, we have ones, tens, hundred, thousands, 10,000. So does that make sense? Vero, I don't know what abacus curriculum you're looking into, because I know there's a bunch, and I don't know where you're located, but there's a bunch of abacus. If you're in Southern California, I have a school out in Monterey Park, and we do in person on the weekends. I do have an online class that I do provide. It's a monthly, but it's at your own pace. Oh, you're in Monterey Park? We're out in Garvey. Yeah. So if you want, you can find us, AMA Learning Center. AMA Learning Center. We're off of Garvey. I think it's 440 Garvey. If you want to, my brother was the one that owns it. Oh, I'm in Texas. I just stopped by to learn. Oh yeah, not a problem. Oh my God, I went there. You did? Oh, there you go. So you had a free trial class. So you know who Miss Joey is. Miss Joey is my sister-in-law. And would I would recommend it? I would recommend it. I would recommend it. Why? Because they get a stronger sense. How did you find us? Were you just looking? That's really interesting. Yeah. That's That's really interesting. Google. Oh, cool. Yeah. So we've been around for so my brother is the one that owns the learning center, and we've been around for about 20 plus years. We've taught the kids around the neighborhood. I just now started going into the internet. Oh yeah. Okay, good. Yeah, that's my brother. Just watching from New Zealand. Oh hey, welcome. So some of the benefits. So did it make sense about the benefits? So the benefits were because your child is interested, I would recommend it. The only reason why is because they get a stronger sense, and then when they go into school, they're going to start learning what Common Core is, and with Common Core, that's what Abacus does. So a lot of the things that we do is how do we add the 5, how do you add the 10? So a lot of borrowing and carrying over concept, it happens within the Abacus. Yeah, I watch from New Zealand. Oh yeah, I have a friend in New Zealand. So here, just to count on the abacus, we have 1, 2, 3, 4, and then we have 5. Because we have 5, the top bead will always have a value of 5. So this is 5, and then this is 6, 7, 8, and 9. So then we have 10. How do I know that this is 10? This is 10 because every column is a place value. Ones, tens, hundred, thousands, 10,000. Yeah. Vera, do you have any more questions? Let me answer them. I'm here, so. And then I know you said one more. And you're getting off. Thank you, Mama Bear. Thank you. I appreciate that. Okay. Yeah. Vero, do you have any more questions? Before I sign off. I'm actually going to sign off. I've been on for a little bit. In their heads? The benefits is eventually they'll do subtracting. Yeah, that's the point, right? The point is that they can do. But the thing is you can do multiplication and division on the abacus as well. So that's what I've been showing everybody. You can do multiplication and division. So the long-term benefit is that it makes them confident. Sorry, my allergies are really acting up. So the long-term benefits is that they become confident in math. I go live pretty often. I go live at least once a day, sometimes twice, sometimes 3 times. So the benefits of abacus is they're strong in number sense. What does that mean? Well, what abacus does, it's the gateway to complex math. There's a framework in math. There's a framework that we have in abacus that translates to algebra. Okay, Bill, I'll see you later. I'll see you in my next live. So abacus is the gateway to complex math. What happens is we actually do is we fill the gaps that happens, because a lot of the things that happens now when the kids are older is that they don't know how to do the multiplication, they're not strong in it, and so forth. And so when we do abacus, there's a set framework. Because we have a set framework, it translates to algebra. So when they're done, I mean, when they're done with the whole abacus and they go into algebra, they'll be like, well, I don't know why I know this, but I know it. So my kid had the same realization, and it's because what we do is we do some substitution. What we do is we do substitution, and we isolate the variable and so forth. So here's a question. So a lot of the things that we do in Abacus is what we do in regular school, but we do it differently because it's not it. What Abacus does is it strips away the complexities. Because it strips away the complexities, we don't have to do too many variations or too many different strategies. We don't memorize our doubles. What we memorize is our formulas. So there's formulas that we happen to know. To know it, to understand it, is how to add a 5, how to make a 5, how to make a 10. And these are, I need to, you know what, Vera, if you want to continue to watch, I'm live pretty often. And if you have any other questions other than that, but like, so in school, we're teaching the kids how to make a 10. But in Abacus, what we do is we make our numbers work for us to help us benefit, how we do certain things. So this is how to make a 5. This making a 5 is what we learn in school. But what Abacus does is we take it one step further and we actually utilize it. So what I did here is I isolated the variable. When I'm talking to you as an adult, not as a child, just so you know. We don't tell this to the kids. We just tell the kids memorize. You know what I mean? So some people might get confused, like, why am I talking about isolating the variable? No. I'm talking about isolating the variable because I want to show the parents what the benefits are to learning, right? Okay, good. So here, what we do is we isolate the variable. When we isolate the variable, you'll notice that if I want to, make an x, it's very similar to algebra, but we don't call it algebra, right? And then what we do is, let's say we want to have the 4 plus the 4 equals to 5. 4 equals to 5 is not balanced. We need to balance the equation. To balance the equation, we have to minus the 1. So to do that, so now what did we do? This is a formula that the kids have to memorize. They need to memorize this formula. They understand the concept. This is what they're taught in school, but now we utilize it and we make it work. So when we add 4, right, the question is 4. I'm trying to find my question. Let me find a question. Because I'm very visual, so I need to like see these things, right? So let me do a question. So my question is 4, again, we know 4 plus 4. We know 4 plus 4 is 8, right? But we're not supposed to memorize formula. We're not supposed to memorize the doubles. Why? Because doubles is one way. Doubles is only addition. What is the doubles for minus? Doubles for minus is just 0. It doesn't make sense, right? But so here is my question, 4 plus 4. Now, when your child goes through the Abacus formula, they're going to know they're going to know there are certain questions that they need to start asking. They're going to have conversations in their heads. So, can I add a 4? No. How else can I add a 4? To add the 4, I need to add the 5, take away the 1. I add the 5, take away the 1. My answer is 8. So now it becomes versatile, right? So this becomes 8. Here's my next question. Let's say 2. 2 plus 4, right? 2 plus 4. How does that work? Well, again, I want to add the 2. I added my 2. I want to add the 4. I know how to add the 4. How do I do it? I go back to my formula. Plus the 4 is equal to plus the 5 minus the 1. So plus the 5 and I take away the 1. My answer is 6. So it's not overcomplicating the process. We look at our abacus and we see what can we do. So it's about critical thinking and providing a framework of how to do it. And so then because they know the rules, because they know the formulas, they know the framework, they'll be able to Tetris their way through the questions. So this actually becomes scalable. So right now we're working with just single digits, right? As an adult, we're like, this is complicated. It's like, no. What it does is it provides a framework and then we can build and scale. What does that mean? Because now when we do, let's say 500 plus 5,463, right? We do that. and then we say, okay, let's say 130, 1, 2, right? We're doing this. Let's say we do this. Well, we're going to, on the abacus, we can do it. Not a problem. We do 5,436. Okay, not a problem. Now what are we going to do? We're going to add this. 1,003. Remember a 3? Do we have enough beads to add the 3? No. So now we know our formula. That's what this is. What we want to do is plus the 3 is equal to, this is a framework. Once we know the framework, we can scale it. So I want to add the 3 plus the 5, take away the 2. So this is 7. Now I add the 1 and I add the 2. Does that make sense? So in the beginning, right, understanding this can translate to understanding this. They just need to see what it is on the numbers. That's it. That's it. Yeah. But it's different when you go in and seeing it. Do you have 16 or 20 week per level? The ones in Monterey Park, it's 16 weeks. So your child would be the 16 week, and yeah. And how many levels? There are, at Monterey Park we do 10 levels. We go, and it goes all the way to multiplication and division. So she'll learn how to do, so I'm sorry, your child, I don't know if it's he or she, your child will go from learning how to do the basics. Then after that, like after like a few months, then they'll start going into doing multiplication and multiplication. And then when we do multiplication, after they do multiplication, they'll start learning how to do division. And then after that, and then they start going into computer listening. So they'll be like listening to the numbers, and then also what do you call it? Flash unzon, which is seeing the numbers flashing. So I might see you there. I'm there sometimes. I'm there on Sundays. I have one student that I have in person. But that's, yeah, that's my student. But I'm trying to do mine online. Yeah. But yeah, it's because I'm thinking that because your child is 5, I'm thinking that they're going to be on the 16 week. I'm not sure what they mentioned. Did they say that your child will be ready for 20 week or 16 week? I'm not sure. Thank you for the follow. Thank you for the hearts. I didn't talk to them, so I don't know what they mentioned. I know somebody, they said 20 weeks. Okay, so then that means it would be 20 weeks because it's at a slower rate. But see, it all depends on how quickly or how slow. It all depends on the pace of your child, right? So if sometimes the concepts might be a little bit more complicated, so then it takes a little bit, if that makes sense. So yeah, I don't know what they said, so but I know what they do, right? Because that's my brother. So if they said 20 week, but don't forget, they can go depending on how quickly or how slow your child is, they will adjust. So I mean, if you hopefully your child will do homework. Hopefully they will do homework like once a day, and if you keep up with the pace of practicing, then it'll be quicker and faster, if that makes sense. How much per class? Didn't they tell you? Um, I would have to confirm. Do you want to do you want to do you want to talk to them, or do you want to talk to me? Yeah. Okay. So, um, it's not by class. It's monthly. Sorry, sorry. It's been a while. It's monthly. So I think I would have to come back to you on that. You know what? Why don't you DM me and let me confirm about the prices and stuff? But it's not per class, it's per month. I believe they're charging per month. And there's makeup if you don't, and if you need to readjust, if you need to reschedule, they will reschedule. I know that for sure. But I believe it's monthly. Yeah. Um, yeah, not a problem. Not a problem. Yeah. DM me if you have any more questions. Um, yeah. and I might see you around. But I'm happy you came on my live and asked the questions. Hopefully it made sense, right? I hope it makes sense. But I know I'm every teacher's different, and I teach differently. Yeah, and let me know if you have any more questions. But DM me DM me, and I'll confirm about the prices and stuff. But I am going to shut down. I am going to log off because I've been on for a little bit and I got to keep working on my stuff. I'm creating workbooks. So I create workbooks and stuff. And I'm trying to make my stuff online. So, but yeah. All right. So I'll see you later. Thank you again. I hope to see you soon. Yeah, I hope to see you too. It'd be nice to see somebody in person. There's another person, Bone Thugs and Harmony, but I don't know if they came in. Anyways, thank you again. Thank you again for the comments and the questions, and we'll see. And then for you, Vera, if you wanted to, like I go live pretty often, but what I do is I talk about Abacus, and I talk to Abacus as adults. I teach kids, but not on lives, not on TikTok, because I'm not supposed to be on TikTok. All right. Have a good day. Have a good night. I will see everybody on my next live. I might go later on today, but I'm not sure. We'll see how see it is. Okay. Bye. Ah, ACL. I'm about to leave. I'm gonna go. I was gonna log off. I'll see you later.